Hi, welcome to our GDP. Basically, we're designing a smart greenhouse system for a customer named Jonathan Lodge, who works with City Farm Systems.
His aim is to put this type of automated greenhouse in urban environments, such as on the roof of supermarkets.
And this way, he can grow the crops at the point of sale, so that is growing the herbs and growing the salad on the roof of a supermarket. So, what he's asked us to do as part of our GDP is to take a basic greenhouse like this, where it moves all of the crops around inside the system, and make it fully automated and closed loop. So this means we're working out where all the trays are at a given time, taking pictures of all the trays, recording measurements of all the trays, so for instance, how hot it is inside the greenhouse, the humidity, the soil moisture of each of the trays inside the greenhouse as well. We've been working on this for a number of weeks, and I'll show you what we've done. Firstly is the wiring for the whole trailer.
So, when the trailer was delivered, we were not able to understand how it had been wired, so we had to strip all of the wiring and start again. This meant rewiring things such as the motor, batteries, battery charger and power supplies.
We've then fitted a number of custom systems into the trailer. So for instance, we have an Arduino microcontroller, which acts as a real-time system. So this is when things such as an emergency stop happens, it can cut all power to the motor immediately. Next, we have the Raspberry Pi, which is also running a server. This is recording the data of all of the Bluetooth low energy nodes, keeping all of the measurements, taking all of the photos, doing all of the RFID scanning, and also running a web server which is accessible over a network connection or on a HDMI connection. Next, let's go around to the back of the trailer. We can see what we've got there. So, here we can see all of the trays in the greenhouse. This would normally be full of trays on every single row, and this means that all of the greenhouse will be completely filled. The trays rotate around the greenhouse, going to the top where it's warmer, and also dipping into the bottom where they can get some nutrients and water. This is where the operator would stand. So for instance, if he wanted to replace one of the trays with a new tray because this one was ready to harvest, he would simply lift it out and then hook the new one back on again. And the server would tell him to do this. So the server would track when the crop had been in, how long it would take to grow, and thus what time it would need to be harvested. The operator also has some controls here for him to use, such as a manual advance of all of the trays, an emergency stop button in case there's a problem, and also LED indicator lights which tell him the state of the system. We can see here the basic program that's running on the Raspberry Pi. The trays are rotating around the greenhouse at a predefined interval which is customizable on the web interface. When the trays get to the end, which is where the cameras and RFID readers are, a photo is taken of each tray to monitor the growing progress of the crop, and the RFID tag scans each tray to check it is the right tray in the position. Also, the Raspberry Pi at each stage is going to connect to all of the sensor nodes and read them. And this happens every time, so you get a lot of readings, and you can see how the different conditions at the top and the bottom of the greenhouse affect the growing of the crop as well. Next, let's have a look at the server interface. So, here we can see what the basic admin user would see on the server. They can see where all of the trays are in the greenhouse, they can see which modules are in the greenhouse, and also if we click on a tray, so for instance tray 9 here, which has a sensor module in, we can see for this test crop different amounts of readings. We've got the light changing over the day, and you can see it's alternating as it goes up to the top of the greenhouse where it'll have a high intensity of light, and then at the bottom of the greenhouse, or when it's shadowed by other trays, where it'll have low light. If we want to input a crop, we just edit the next crop that's going to go in. So for instance, coriander, insert it to yesterday, and then we need to harvest that tomorrow, and that'll be saved. So now we can confirm that it's planted, and for this crop, say tray 2, we can see an image of the tray. Here it's got nothing in it, but you can clearly see the 2 label indicating that that is in fact tray 2. An admin on this can also edit the positions of all of the trays, queue up next crops to be planted, and also change all of the configuration of the server. So for instance, how many trays are in the system, how many nodes are in the system, and what the MAC addresses of the individual nodes are. You can also change the sleep time.